Here we determine the order size so that cost per unit is minimum. So first we have to determine the average cost using this cost function. The average cost is given by this formula, and this equals this cost divided by x. So let's determine this average cost. And so this equals 5x squared plus 320 divided by x. And so this equals 5x squared divided by x plus 320 divided by x. We can simplify this, and this equals, I can cancel this 1 power of x with this x, and so this equals 5x plus 320 over x. And so this is the average cost function. We can write down this as c bar of x, and we want to determine the size such that this average cost is minimum. So that can be determined when we set up this equation, that is c bar prime of x equal to 0 and solving for x. So it's basically finding the critical point of the average cost function. So let's do that. I'm going to differentiate this average cost function with respect to x. So I write c bar prime of x, and this equals the derivative of 5x is 5 plus the derivative of 320x. We can write down this 320 over x as 320 times x power minus 1. Now we find the derivative of x power minus 1, which is when we use the power rule, minus 1 times x raised to the power of minus 1 minus 1. And so this equals 320 times negative 1 is negative 320 times x raised to the power of minus 2, or negative 320 over x squared. So therefore the derivative of 320 over x is basically negative 320 over x squared, which I replace it here. So it becomes 5 minus 320 over x squared. Now we have to set the equal to 0, that is the average cost function. So this becomes 0 equals 5 minus 320 over x squared. Now let's solve for x squared or x from this equation. First I add 320 over x squared to both sides, and so I get this equation. Now we multiply both sides by x squared. So we get 320 equals 5x squared, and we divide by 5 on both sides. So we get 320 divided by 5, and this equals 64. So 64 equals this 5 and 5 gets cancelled, x squared. Now we take the square root to solve for x. So we get the square root of 64 is plus or minus 8. Since x represents the order sides, we take the positive quantity, that is 8 equal to x, or we say that x equal to 8. And so using this value of x, we can check if the average cost is minimum at this value of x. For that, we have to find the second derivative of the average cost function. So I'm going to find the derivative of the average cost function, that is the first derivative of the average cost function. So I write c bar double prime of x, and this equals, we find the derivative of this expression. I can write down this as negative 320 times x power minus 2. So we have to find the derivative of this one. So I write negative 320 times, I put this power in front, that is negative 2 times x raised to the power of negative 2, negative 1. And so this equals, this is a positive number, that is 640 times x power negative 3, which I can write as divided by x cube. So it is 640 over x cube. And we can plug this value of x equal to 8 into the second derivative for average cost function. And when we do that, we get 640 over 8 cube. And this is going to be greater than 0. So since the second derivative is greater than 0, we see that at x equal to 8, the average cost is minimum. Therefore, we choose the answer choice B, that is an order of 8 units has a minimum cost. 8 units as a minimum cost per unit. Choice B is correct.